Hi everyone, welcome back to one more episode of True ML Talks. I am Nikunj, co-founder and CEO at True Foundry, and with me today we have Ezequiel, who is an open source AI evangelist at Intel, and he has kindly agreed to share his wisdom that he has gathered working years with multiple developers and evangelizing AI in the overall community. Ezequiel, I welcome you to introduce yourself to the community here.
Yeah, sure. Hi, thanks for having me. It's a pleasure for me to be here. And yes, my role basically what I do is AI open source evangelist. I do the evangelism for the Intel open source tools that we have. But I also like to to participate in the community. I like to provide blogs, tutorials, videos, not just focused on Intel, because the community we all share the same way to share the things. Once you do something, it's good to share it, even if it's Intel or it's not Intel. So I like to have this kind of mindset, the open source mindset, right?
I love it. I love open source myself, and I'm very curious to hear about your journey. Ezequiel, tell us a little bit about how did you arrive at this position? Like how did you arrive to the point of what with doing what you're doing today? And just how did you get interested in this field? Tell us a little bit more.
Yes, the evangelism part is something that I probably did for a lot of years. I mean, for the last 2 years, I'm in this same role. I mean, evangelism with AI and so on. But my previous role, they were related with pre-sales, trying to advocate in the software. I worked for a few years in Genesis, which is a contact center solution. Um, I was working on pre-sales, helping the developers to adopt the technology, the old NLP technology, which is 5 years old or 4 years ago, which seems to be old now. But yes, I've been working with that a lot of years, and also with some pre-sales in Cisco and data center and Kubernetes and so on. But I started to move or to try to be 100% focused on AI when I started to do my master's in data science. And I said, I would like to go deep in AI. I would like to machine learning, computer vision, and everything. And hopefully something that I've been doing for the last, we can say 4 or 5 years. Uh, Hardly. I mean, developing and not developing a solution, but trying to help others to use the technology. Because I always feel, because it's something that happened to me, this gap that once you like to see a tutorial or once you like to do something, it's probably not easy how the document is written or how the code is written. So it's very hard if you like to test something. So and I said, okay, I would like to be in that position. I would like to be the one that can talk to those developers and can do the introductions to say this is how you use the technology, and in a not technical and in a very easy way. It's a mix between. I'm not saying that I'm marketing. I'm very technical, but I have this mindset of okay, let's try to speak in a very easy way, because it's something that we experience always.
Makes sense. Understood. So Ezequiel, this is super exciting. So you have actually made relatively a big career transition for yourself, basically working from pre-sales to doing a master's in data science to now doing the evangelizing. It's very cool. Was it I speak with a lot of members in the community who are also interested in not coming from a data science background and kind of getting into this field. Maybe share a minute or two, how was that transition for you
Yeah.
just personally?
Yeah, I mean, data science or AI, I mean, if you know the details, it's better, of course. I mean, if you know the statics behind the algorithms or how it works, it can help you, of course, but it's not mainly mandatory. You can work, for instance, in MLOps, or you can use the models, or you can have an idea on how a computer vision algorithm works, but you are not developing the neural network or the convolution neural network. So probably you roughly know that, yeah, there are some networks, but you work with the outputs that you get from those models. So you can be an AI developer and you just need to know how to code, of course, but what you do with once you get an answer from an AI model, what you can do with that, and how is this cycle? Okay, how can I improve the model? What should I do to improve the model? And that's it. With because you can be in the data scientist role in AI world without knowing all the details, of course. Of course, if you are in the research and you are creating new architectures, or if you would like to see how a GPT works or how a transformer really works, um, because you would like to improve it, because you may see, okay, I would like to test something. I would like to mix, convolutional neural networks with transformers, with RNN, and so on. And now I would like to see if it performs better. You would like to be building a foundational model. In these cases, you of course you need to have a master's or a PhD, or something more deep. But it's not absolutely for me. It's not mandatory. I decided to do that because my degree is engineer, and as an engineer, I like to go deep on things. Probably for nothing, but I would like to go deep in some things. I don't know. I have an oven on my microwave. I would like to understand how the microwave works, for instance. For what? For nothing. Absolutely for nothing. Um, but this curiosity that I had, I said, okay, I would like to see what is this neural network, what it is. 5 years ago or 6 years ago, it was probably not so easy to understand. So and I went to that space, and because I know, because this is my mindset, right? Because what I think is, the most you know, it will help you to do the very easiest. The easier things, you can do it if you know a lot, but it doesn't mean that you need to know it.
I see.
It's not how I work, right? In my mind.
That's a really good way of thinking about it. You can get started. You don't have to get like bogged down with all the details. You can get started with something at a high level. Then of course, if you're curious about a certain topic, you keep going deeper into that, and you kind of start becoming more and more of an expert. So it makes a ton of sense to me. All right. So
Absolutely.
Ezequiel, talking a little bit about Intel, right? Of course, Intel has been super active in a lot of open source work that Intel is doing itself, but would love to hear directly from you, like, what are some of the initiatives that you are taking, as a company that, in fact, you are driving as an individual. What's the impact overall that you're primarily trying to drive with these initiatives? Would love to hear about that.
Yeah, basically what Intel always embraced open source. Since Linux in the past, we were the main contributors to Linux, and this is a kind of culture that we have inside, that we can face within the company, right? Basically, what Intel is doing in the AI scope is, we have hardware, of course, because we are a hardware provider company, but this hardware has some accelerations built in, right? So uh, what we do to provide, or what we contribute to the community and to the AI scope overall, are contributions to people, so they can use these accelerations. So how you can use it, and this is the part of the message that we have, that is, we try to democratize the usage of AI, because every toolkit or every library that we have in our hardware, what we do is we try to upstream those libraries or those accelerations to PyTorch, or to the main frameworks, that is PyTorch and TensorFlow, right? So the main goal there is, okay, you don't have to learn a new language because it's already built it on PyTorch. You don't have to change your code. You don't have to do nothing, basically. It's just we providing something that that can be transparent used by the users. If you are using PyTorch, for instance, now you natively have an optimization. So this is one concept, that we have optimizations, we upstream our libraries to the stock version so they can be able to use it. The other option is, once is the acceleration, that we can talk deep later, of course. But once is the acceleration, but the other is, there are a lot of tools in AI that you need to use if you like to optimize models, if you like to accelerate your workload. Now with the LLMs are huge models with billions of parameters. Okay, how can I work, or how can I build an application in a CPU processor, for instance, because I would like to make it cheaper, but I would like to make it faster, and I would like to use it. So there are some tools that are not in the main frameworks, that are open source, and that people can use it, and they are probably optimization tools that you can use underneath. So it's basically, the concept is, and all the tools that we wrote, they are all in open standards. So
I see.
if you are writing a framework, for instance, because some people, they don't like to use PyTorch, or they don't like, or they don't, or they can't, for instance, because they don't have the memory in their solutions and so on. So they say, okay, I would like to write this function in C++. I would like to go deep. So in that case, the libraries that we enable, they are written in C++ or SQL with our open standards. You don't need to learn CUDA, for instance, if you would like to use it. So that's the main difference, or that's the main concept that we try to use. Well, every time we create something, we create it in open standards, right?
I see. So like, not dependent on a certain framework, but like you could like literally take the piece of code as an accelerator and like, build out, deploy that in wherever you want in some way. Run that. Yeah.
Yeah. It's we have different kind of developers. The developers that are more on the top of the stack. I mean, the developers that use a framework, that use PyTorch. You can use the accelerations without changing your code. You just have
Right.
to enable the acceleration, and that's it. But some people, they don't use PyTorch, which is other kind of developers that are in a other level on the stack. And probably these developers, they will like to say, okay, I don't use PyTorch. I
Right.
go deep and I build my solution in C++, for instance, because it's faster. We know that C++ can be much
Makes sense.
faster
Yeah.
if you use the framework. For those developers, we have the same library, but instead of accessing through PyTorch, you can directly access to those libraries, which is the umbrella of one API, if you probably heard that.
I see. Yeah. 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 Understood. Got it. Okay. Very, very helpful. And like, of course, like, Intel being a hardware company, is there any like, new stuff that like, I guess Intel is recommending in terms of like, the generative AI training and deployment? Like, I personally, by the way, come primarily from a software background, so I also
Yeah.
don't have like, as much understanding about the hardware stack. So would love to hear a little bit about that side.
Yeah, no, that's a very good question, and something that now, if we are working on software, you probably, it doesn't matter the hardware. I mean, it's just a hardware. But what we have as an offering is two big families. The first family of the CPUs, which is all the Xeons that you may find on the data science, on data servers, or data centers, or cloud, for instance, on instances. Most of them, they are powered with Xeon processors. With There is a kind of acceleration that you have there. That is something that I mentioned. That is the acceleration that to make the model fit, for instance, in a CPU. And this is a new generation every time. That it's, I mean, how they handle the memory bandwidth. A very hardware conversation, but it's improving, of course, generation after generation. So this is one family of models, and there is other family that is our GPUs. We have a Gaudi, which is part of the Habana Labs, which is a company that Intel acquired 5 years ago or 6 years ago, I think. And all the workloads that are very GPU intensive, the proposal that we have for these workloads is, okay, if it doesn't fit on the CPU, if you don't have a way to use it on a CPU, okay, we have the GPU that can help you on that, which is basically on the same concept that we can have on the CPUs, right? It's the same libraries, is the same one API umbrella, it's based on standards, and so on and so on and so on. But this is something that we didn't have probably 3 years ago, or 3 years or 2 years ago. We didn't have a discrete GPU. So now we have this GPU that is built for data centers. I mean, it's not a gaming GPU, it's not a GPU that you can put in your workstation. It's a huge GPU that is available, for instance, in AWS. If you would like to use it, there are some instances that are powered by Habana Labs, or plus the Xeon processors. Right? So basically, and we can talk about the family that the edge, for instance, some workloads or some inferences you may need to run it on the edge, like
Right.
cameras. If you are using computer vision, you need a camera to run the inference there. So there is another family of CPUs that are more client CPUs or close to the CPUs, close to the laptop or client, that it can run AI algorithms also there.
Understood. Got it.
Yeah.
Okay. So, these GPUs, these large GPUs that you mentioned are available through some of the cloud providers like AWS. Are you all
Mhm.
also doing some sort of integration with other data centers, besides the major cloud providers, or this is the primary way of distributing the GPU, like bringing the GPUs to the end consumers?
Yeah, the idea is to have it everywhere, not
Hmm.
just focus on on AWS or in CSPs. Uh, Due to the size of the GPU, you cannot go you and buy one GPU to have it in your home, for instance.
Yeah, yeah.
All these kind of GPUs are sold to service providers or partners or next wave CSPs or companies that they would like to build. And it happened, for instance, that it's a very new business for Intel, but we are working with companies that are proposing or trying to sell LLM as a service, for instance.
Hmm.
For those companies, there is an agreement and they power their data centers with GPUs, with our GPUs, and they sell as a service. And there is another thing that is not for production. We have Intel Developer Cloud, which basically what it is, it's a kind of sandbox. Because what happens is, like as you said, I would like to test Habana. I would like to test these CPUs. I would like to test it. Probably you don't want to go to AWS. You don't want to buy it, or you can't buy it. So Intel the Developer Cloud, the goal is to provide you a sandbox so you can test these
Right.
GPUs and you can test the performance of your solutions, basically.
Makes sense. Makes sense. Awesome. Cool. I'm gonna switch gears a little bit here, and I'm gonna talk a
Cool.
little bit about some of the I was going through your profiles. Obviously I've been following you, and you published some very interesting blogs. And you touched a little bit on the sandbox environment, running your experiments in there. And the blog that you had written was around optimizing large language models, which is a topic that's of interest to many of us today, right? So again, given your background in open source and all, can you talk a little bit about that, what are the sort of optimizations that you are seeing in the space of open source LLMs? You talked a little bit about Dolly in your blog as well, so
Mhm.
anything, but
Yeah.
Dolly was a few months ago, so any updates that have happened since you wrote the blog, so would love to hear a little bit about that. Yeah.
Yes, I mean it's happening every week or every
Yeah.
day. You can find something new, so it's very crazy. Um, yeah, what I've seen on the terms of LLMs or how to optimize is how or at least how I see the world works on new projects is that we had GPT, we had BERT, we have everything, and the goal or the first goal of them is to trying to find a model to solve a problem or try to be disruptive, right?
Right.
Because ChatGPT, even if we used GPT on Hugging Face 2 years ago or 3 years ago, I mean, it wasn't on Hugging Face, but not in the conversational way. So most people can use it. Most non-technical people can use it. And now it exploded, right? But when you see they are huge models, they are models with billions of parameters, with huge models. And there's a trend for the last 2 years or 3 years that it's okay to have huge models, but if we would like to use it to build a chatbot for a finance company, it will be probably impossible for this company to use this model because it's huge. So they will need to buy data servers, GPUs. They will need to buy the instances. They will need to pay a lot for services and so on. So there's a trend to say, let's try to reduce the size of the model, right? And basically, one of the tools that we can that they are available, it is, you have these huge models and you can do quantization, or you can do low bit representation, which basically what it is uh, and I will try to explain it in a very simple way. When you have a neural network, and and you have weights between networks, right? So it's not a neural network. LLMs, they probably use transformer, probably 99% of the transformers plus something, but just to make it easier to understand, they have weights, right? If we work with AI, we have weights, right? So the way to represent this weight is with a value. So this value can be a float, can be a huge value, can be, I mean, zeros and 20 numbers or 30 numbers to represent below. I mean, the zero, you have 20 numbers, right? It's a float. Um, One of the ways is, okay, let's try to reduce, instead of representing with a float, we can try to represent that number or that weight with an integer. I mean, integer. Like, instead of a float, you can represent it with an integer. In terms of the memory footprint that this model will need, and as I said, we have billions of parameters. If those billions of weights, we have a way to reduce, to dramatically reduce, instead of representing them with floats, we start representing them with ints or with other kinds of representation that is lower, it will drastically reduce the size of the model. So that's one goal when you are doing the quantization or this low bit representation.
For sure.
But it's okay. But I mean, would I have the same results? Because I mean, the model is learning the weights. So if you start changing the weights, you will say, okay, I will be changing my accuracy. So that's one of the challenges, and this is why there's a lot of research in the middle. And you can use it now. I mean, it's something that we can use it. There are multiple ways to optimize the model, that to reduce the size of the model without losing accuracy. So you have similar accuracy, but you will be gaining a huge advantage in terms of memory footprints.
Sure.
So basically, what we do, or what you can find in the LLMs, is that, okay, we downloaded the Dolly model for a reason, because it's open source, because it works well compared with the amount of parameters that it was trained. It was at 3 billion parameters, which is nothing compared with the other ones.
Right.
But it works pretty well. I mean, pretty decent. I mean, I like how it works. So what we say is, we pick the model, we try to reduce it even more, and we make it fit in the CPU. So the result is, you can use an inference, or you can use a GPT, another GPT, a Dolly, and they fit in the CPU. And that's very important, because it's not just try to make it fit on the CPU. It's because you will reduce the spending, you will reduce cost, and you will reduce a lot of things, because what we can think that you need an expensive GPU for inference, always talking about the inference,
right?
You can make it fit on the CPU. So it's a huge advantage. And there are tons of tools and lots of techniques. And as you said, now it's quantization, it's low bit representation. There are multiple, but probably in 2 weeks there will be tons more, and you will be never updated. But the concept it's pretty similar always. Try to make it, to reduce the way that the model is represented, right?
That makes sense, yeah. And I mean, like, this idea about quantization, low rank adaptation, these are the things that, like, kind of like the state of the art in terms of how you optimize the model performance in some way. Like, could you tell us a little bit? You talked a little bit about the Intel extension in the blog as well, like, extension for transformers. Like, what's the role that Intel extension is playing in this? Like, explain that to our audience, basically. Yeah.
Yeah, basically is, if you would like to do the quantization, and this is why you may find multiple tools that Intel propose in the open source, because it depends on on what you would like to do, you have multiple tools. Intel extension for transformers, basically what they do is, as we said, GPT or LLMs, they are based on transformers. So this is a tool that will help you to optimize or to define the optimization for a particular transformer architecture. So but the main difference is that you will need to know what you would like to do, which is probably different. You can say it's a tool that make it easier for you if you are a developer and you say, I would like to do a quantization. How can I do a quantization of llama model or alpaca or whatever? Sometimes it's not easy, of course. What ITREX does, Intel Extension for Transformer, which is ITREX, it's a tool that can help you and to make it easier if you would like to do the quantization. And you can select, I would like to use alpaca, I would like to use the quantization to int 8, to int 4,
Right.
to whatever. But you need at least you are in this is why the conversation I would like to separate between some people would like just to use the optimization and that's it, and don't want to go in details of which kind of optimization could work better for a particular model.
Right.
So if you are in the process that you would like to play with optimizations with optimization, quantization, and so on, uh, Intel extension for transformers, I never remember exactly because ITREX is a tool if you would like to use it, because it's pretty easy. But you need to know what you are doing, right?
Got it. So it's very interesting because, like, of course, all the other frameworks that we talk about, like, your PyTorch and TensorFlow, your libraries like Hugging Face, they also provide you tools, right, to kind of, like, manage different types of quantization algorithms. So, like, would you say that this is like similar to those tools? Like, it has some advantages compared to those tools, or it's like a layer on top of them? Like, how should we visualize ITRX compared to these
Yeah.
other tools that allow quantization?
These tools has the advantage that it's an API that you can use, and
Right.
it runs on any hardware that you would like to use it. This is agnostic, but it has the disadvantage that if you would like to use this acceleration that I mentioned on the CPUs,
Mm,
these tools, what they do is while they are doing the quantization, they are kind of preparing the model to use those optimizations, those hardware optimizations.
got it.
So that's the main difference between one and the other. Um, for instance, they use LoRa.
Yeah,
So you can use LoRa and Intel extension for transformers, and you can use LoRa in, as I said, PyTorch or in the open source. But the main difference is that, okay, if you like to use LoRa and you would like to take the extra advantage using Intel hardware, the way that the model is prepared or the way that the model is optimized, if you're using an Intel, you will have a different benefit. It doesn't mean that it just works on Intel because it works in any hardware.
got it.
But if you are using Intel hardware, you have an extra benefit.
I see. Could you maybe, like, help us understand through, like, some numbers, if you have, like, so like some benchmarks about what type of performance gains can people get if they are combining the hardware advantage together with, like, the software interface, compared to, let's say, if they were not leveraging the CPUs, as you mentioned as well, basically. Anything in terms of latency gains, cost gains, if you can share some numbers with people.
Yeah, cost. Yes, I need to. I can say some numbers that I remember. I need to check, of course, if it's what is the exactly number.
Right.
But probably if you use those optimizations all the time, it's a mix between which kind of optimization you do and which kind of hardware are you using and what is the configuration that we are using sometimes. But for instance, for the Dolly model that is something that we prove on GCP using using Intel Sapphire Rapids, which is the latest version of the CPU. You can get up to 40% or 50%, if I don't recall bad, benefit of performance or how faster or how you can improve the latency, right? In terms of cost savings, there is a cost saving associated, of course, and it will depend on each hardware you are using. If you would like to compare instances, you need to do a study, just compare this instance with the other instance. We are not sure if there is in that way you can find, I don't know, this instance, how it compares with this instance, and what is the cost difference if you are performing one particular model.
Got
There
it.
are some particular studies that we published, but I mean, it's just some studies that we can use. This is the same for the Dolly and the GCP and so on, but you don't have for all of them related with costs, right?
Makes sense. I understand. I think this is very, very helpful. And maybe one last question from the same topic, same blog that you also talk a little bit about some of the hardware acceleration. So far, we talked about the CPUs and the combined hardware software interface that we talked about. But then there's also this the fourth gen Intel Xeon scalable processors that we talk about, right? Um, what's the role of this hardware acceleration, and again, what type of impact have you seen using these? Yeah.
Yeah, basically is we know that the CPUs, they have cores, and what Intel is doing in the last two versions is we are adding some submodules inside the CPU. If you would
Hmm.
like to run, for instance, for AI, it's called AMX, which is probably some people can know AVX 512 or AVX 256. Now it's called AMX, which is basically a matrix acceleration. So when you are working with computer vision, or any case, or deep learning, for instance, the matrix calculations that you have, the way that these matrix calculations are done, they are done on the CPU, right? But there is a way, so you can say, okay, instead of running on the CPU, which is a different way to operate, it's a very hardware conversation, but it's a different way to calculate and to separate how you do the math internally. AMX, instead, for instance, something that can take 2 cycles or 3 cycles in the CPU, you can do it in 1 cycle using this AMX portion of the CPU. So this is why it's accelerated, right? It's not because it has more frequency. Yeah, it has more frequency, it has more cores, and so on. But the main difference is that the way as the operations are done are completely different.
Got
And
it.
the matrix calculations, they are, I mean, everything that we do with AI, it's a matrix calculation. So if you have something that can do in a different way than a CPU does, you can have an extra benefit. And usually it's in that way. If you want an operation that takes probably 2 cycles of CPUs, you can make it in 2 or 3 cycles. You can make it in 1 cycle. Of course, it depends on the data, it depends on everything, but it's always that kind of reduction. Probably we can talk about 50% or 60% in some
Wow.
particular.
It's amazing. Awesome.
Yeah,
So
and it's a very deep conversation on how you represent the vectors. I mean, it's a
yeah,
hardware conversation, but how we enable that at the upper layers, it's through those libraries, which is the one API umbrella, one DNN, one math kernel library. There are some libraries that allows you, for instance, the convolution. Okay, once you invoke the convolution, instead of using the CPU, you say, I would like to use AMX to perform this convolution.
understood. Makes sense. Super nice. Um, I wanted to switch gears a little bit and talk about the BigDL LLM. Tell us a little bit more about that. Like, what is it? Why did Intel decide to build that model? Why did you all open source it? What's the problem that you're trying to solve, basically? Yeah, a lot of people
Yeah,
may or may not be
yeah, yeah.
familiar. Love to hear some background on that. Yeah.
Yeah, BigDL, as we said, there is another tool that it's, if you're a developer that is using a framework and you would like to use the framework, you can use the acceleration for the framework. And if you would like to do the quantization, you go to INC, to Intel extension for transformers. But sometimes, for instance, you would like to have a more holistic view, and you would like to use an API to make it easier on when you are deploying something, when you are deploying your LLMs, when you are deploying your serial network. BigDL is basically, this is what they do, right? It's a toolkit, it's a library that is open source, that it was initially created to, it works with the Spark databases. So the way that it started was, if you're using AI in the past, you're using data science, and probably would like to train a model, and the way that the model can be accelerated apart from the acceleration of the hardware and so on is if you use it with Spark. So the way that it can handle the data underneath is using Spark. This, I mean, it was started 10 years ago, but now there is a similar way. There's a new library that is called BigDL LLM, which has the same concept, is that if you like to use LLMs, if you like to train LLMs, the first way is you need a library that can be easy to use, and it can also work with LangChain, but it's more on the top. It's more in the orchestration.
Right.
And so it makes the orchestration, of course, with the hardware. So the good thing is it's easy if you are doing with LLMs and you would like to use a llama, but you are very familiar with the Transformers API. So BigDL has their own version of Transformers API, so it will be very transparent. But the main benefit is underneath, if you like to use in a hardware, independently, if you like to use a CPU or GPU or whatever, is just a flag that you say, this model, I would like to run it on a GPU. And just doing that, because of the algorithm, of course, BigDL knows which kind of adaptations they have to do to run it on the GPU, or the kind of modifications they have to do to run it on the CPU. It's basically we are trying to separate the layers that we have with this hardware and try to make it more independent. He tried to make the software that is over the hardware to make it more agnostic and more independent. So you don't have to worry about the hardware. You just say, this will run in a CPU. Okay, these are all the plugins, all the things that the model has to use to run it on a CPU. And same for GPUs.
I see, I see, I see. Got it. Very interesting. So, like, again, like, similar angle about, like, bringing in the hardware, like, the software framework on top of that, like, almost like a hardware cognizant software framework in some way, basically, which is like, seems like the theme about the stuff that you're launching. Again, like, talk to us a little bit about results, like, any benchmarks, any experiments that, like, you've done, you've published. Yeah. And what are the use cases where you would recommend people to use BigDL LLM, like, from a practical standpoint?
Yeah, basically, when you would like to use it when you would like to do this conversion, instead of as you can do it with Intel extension for transformer, that you have to download the model, you need to decide which quantization you need to adapt and so on. That helps you on that. This is an extra layer. So if you like to download llama in int4, you just say, give me just one line of code, and you say, give me the llama in int4, and it makes all the optimizations underneath. And even if you are using the API that is in the transformers, and you can also integrate that with the pipeline with LangChain. So if you are trying to reduce, or if you say, I would like to use it on my PC, I like to run it, I like to test it on my PC, you can do it. And this is one of the main concepts that BigDL has in this BigDL LLM, is the idea is to provide XPUs, which for us XPUs is Intel are the processors from the laptop to the cloud, right? So it's something that you can use it, laptop, GPU, and cloud. So you can use it on your laptop with your client CPU. You can use it in Windows GPUs. You can even use it in a gaming GPU, and you can also use it on the cloud CPU or GPU. Always talking about Intel now, right? So basically, if you are finding an easy way to try to test an algorithm, to try to test a llama in your computer to see how it works, BigDL is a library that can help you on
Got
that.
it. I see. Understood. Got it. Super, super nice. Okay, cool. I think this is very, very exciting. I think our users are going to love this conversation about how Potentially people can run llama in their own laptop. A lot of it will unlock a lot of, I guess, development creativity, basically, because people don't have access to GPUs sometimes. Like, indie developers are not able to afford the GPU, so there's a lot of benefits that people will get with that. All right, one last thing. Given again how closely you're associated with the open source ecosystem and AI, what are some of the trends that you are seeing or you expect to emerge in as we move into 2024? Where do you expect a
Mhm.
lot of open source development and
Yeah,
impact to come in from, basically?
yeah, more conceptually talking. I think that LangChain it's will be improving. I mean, will be now it's adopted. The adoption for LangChain is very good. So I think that will be the de facto tool that if you like to use LLMs,
Yeah,
and this is a personal perception, I think that it will be growing even more, because we have LLMs. Most people would like to use it, and people is looking for tools, right, to use it. And it reminds me of your first or your second question. So, why do you need to know a lot of something if you like to implement a solution? Say, why do you need to learn int4, int2, or quantization or pruning? Uh, if you like just to use, you don't want to understand how the vectors are calculated. So, tools that are aimed to help the developers in their implementation, for me, will be a game changer. There will be a lot of tools, and they will be growing even more. The other ones is also optimizations. Um, they are trying to make it lower and lower and lower, and the models, so they have to fit it. Even when you're fine tuning, now the models, they are big, they work for everything. And but now the models, if you like to use it, you don't want a model that probably will know who was the second president of the United States. You just want a model that can help you on your finance problem, right?
makes
So this
sense.
fine tuning and so on, that will be, and the optimization of this kind of models for me will be crazy. One little detail is that why do you need an optimization? And just a pretty technical detail is just they're using transformers underneath, right? And there is an attention layer. I mean, LLMs, they basically use the transformers architecture,
Right.
and which is basically a transformer with attention layers. Attention layer, how it works is every time that you feed, for instance, a prompt, they are calculating or they are comparing to find this attention or the importance of the word to make a prediction for the next word. Um, they are comparing the input, let's suppose 10 words. They are comparing one word with all the other words to see if this word is important.
Right.
The second step is they go to the second word and they compare it to the other ones and they see how important it is. The third step is with the third word, and so on and so on and so on. So every time that we are growing on the prompt or on the question that we do to these models, there is a quadratic complexity that the operations are exponentially growing. So the optimization basically goes on that side when we talk about attention layers. The way to reduce the attention layer is how they do these optimizations or how they do this operation. Instead of growing in these multiplications between them, there is some ways that you can do a likelihood, or there are techniques that you can reduce this kind of operations. And this is a research topic. It's a very interesting research topic, which I will see that will be growing and growing and growing because the models are getting bigger, bigger, bigger. And even if the hardware is increasing, we're trying to make it fit, of course, because at the end of the day, we need to have cost-effective solutions, right? And the other one, which is more in terms of the concept, is responsible AI and explainable AI. We talked about optimizations, we talked about hardware, software, PyTorch, and everything. But once we are implementing those models, they can generate a question, they can generate content. Even if they are not so creative, we know that how they create is word by word, right? Um, but they are creating something. So the way that they create it could be racist, it could be biased, and it could be, I mean, it's creating based on the internet access or the data that they can access. So for me, responsible AI and explainable AI will be the key, because if you like to use it in a finance or in a healthcare, you need to really be sure that the model will behave the way as you designed it to behave, right? No racism, no nothing. So there are techniques that you can protect that and so on. But it's the same with optimizations. It's a very hot topic on research on how you can explain how
Yeah.
an LLM work. So these are the main trends that I may see for 2024. It could change in 2 months, right?
Right.
But at
Yes.
least now, yeah.
I mean, yes, for sure. I think with all of these, we make our best guesses, but of course, things can change. But I think it's still good to kind of have like some frame of mind that we think things are going to evolve in, and then being flexible with what's really coming out there, basically.
Absolutely.
But thank you so much, Ezequiel. I really liked speaking with you on this, going learning about some of the things that especially about the hardware side of things that I don't have a lot of background in. So got to learn a lot from you, and I'm sure the community will also benefit from this talk. So I thank you so much for taking the time.
Thank you so much. Thank you so much for the invitation. And well, if you have any doubts or any comments, you can reach me out on my LinkedIn account. So thank you so much for your time.
Appreciate it.